Right, good evening. Can you hear me? Can you hear me? Mama kata කරන එක ඇහෙනවද? Can you hear me? Students, can you hear me? ඇහෙනවද මං කියන එක? Yes or no? Yes. Right. So, yes, right. I think I just explained regarding started the hypothesis testing, and then that is section 2.6 or 2.7. 2.6 is over. 2.6. Even 2.6. Do you have the so then type 1 error, type 2 error, one tail test, two tail test? So everything I think is okay. One tail test, two tail test. So then what is type 1 error, type 2 error and all? Yes or no? That day last class? I think last Wednesday. What is type 1 error? What is type 2 error? At section 2.6. All completed? හරි ඒ ටික කරාද මම type 1 error type 2 error නම් මට මතකයි මම කරා ඊට පස්සේ ටික කරේ නැද්ද 2.6 එකේ power of test alpha beta critical value critical region ඒ ටික කරාද මම නැද්ද ඒ ටිකද කරන්න තියෙන්නේ type 1 error type 2 error නම් කරා මට මතකයි power of test so what about the test statistic critical value directions locating the critical region ඒ ටික කරේ නැද්ද one tail test and two tail test up to that to be completed ඒ ටිකද කරන්න තියෙන්නේ මතකද ඔයගොල්ලන්ට කොයි හරි ඉද කරන්න තියෙන්නේ type 1 error type 2 error වලින් පස්සේ ටික කරන්න තියෙනවද ඒ ටික කරන්න sorry කියන්නකෝ
ඒ ටිකත් කළා මේ පුළුවන් නම් ආපහු මතක් කරගෙන යන්න පුළුවන් මිස් ඒ ටික
හරි ඔයගොල්ලන්ට ඒකම 2.7 එක ආවද ලෙසන් එක නැද්ද මම හිතන්නේ නැතුව ඇති නේද නෑනේ මෙහෙමයි මම මේක ඉවර කරලා ඔයගොල්ලන්ට මම 2.7 එක එවන්නම් මොකද දන්නවද මේ අද උදේ පවර් කට් එකක් තිබුණා මට මේ දැන් කරන්ට් එක ආවේ මට මේ ෆොටෝස් ගන්නවත් මොකුත් උනේ නෑ එහෙමනම් අපි මේ ටික මතක් කරලා මම 2.7 එක ෆොටෝ එකක් ගහලා මේ ඔයගොල්ලන්ට මේ දාන්න ඔයගොල්ලෝ පොඩ්ඩක් ඩිස්ට්‍රිබියුට් කරගන්න මොකද මොකක්වත් කරන්න ඕනේ නෑ ෆෝන් එකේ බැටරි තිබුණේ නෑ පොඩ්ඩක්වත් මේ අපි එහෙනම් මේ ටික ආපහු මතක් කරමු 2. type 1 error type 2 error ටික මතක් කරලා 2.7 එක මම ඔයගොල්ලන්ට එවන්නම් හරි so then what will happen once we are going to the testing hypothesis? So I just explained how to write the null and alternative hypothesis. So what is the hypothesis statement? Is the one statement. So then based on a population, population parameter. So then we are going to check whether is it true or false based on sample data. That is our testing hypothesis procedure. අපි දැන් මේ දීලා තියෙන population parameter එක හරිද වැරදිද කියලා බලන්න sample data අරගෙන අපි මේ ඒක හරිද වැරදිද කියලා තහවුරු කරනවා. But what will happen once you take the population is not a sample population. So then once we are using any kind of the sampling techniques, so then more suitable sampling techniques from your population එකට හරියටම ගැලපෙන sampling techniques අපි ඉගෙන ගන්න තියෙනවා. ඒ sampling technique එක අපි පාවිච්චි කරුවා some population is not 100% equal to the sample. So it's a representative. So then there may be a small error. So because of sampling errors කියලා තියෙනවා. So then, because of that, the two types of errors can be occurred. When the errors දෙකක් තියෙනවා. So one is called type 1 error, the other one is type 2 error. What is your type 1 error? Type 1 error is when the rejecting the null hypothesis. So then, using the sample details, once it is true, is called the type 1 error. Type 1 error is what? So then we know our null hypothesis is correct. අපේ null hypothesis එක හරි කියලා දැනගෙන උනත් so then our testing procedure so gives that is wrong. ඒ කියන්නේ ඒක වැරදි කියලා අපිට දෙනවා. That is called type 1 error. අර මම ඕගලන්ට උදාහරණයක් කිව්වා. Like so then the students they studied hard. So then 99% of them can get very good results. හොඳට පාඩම් කරපු ළමයිට හොඳ ප්‍රතිඵල හම්බුනා. So then there may be some students in unfortunately. So then they are studying very hard, but so then they can't get the very good results. So that is like type 1 error. So then the null hypothesis is actually true, but it is rejected through the testing process. That is type 1 error. So probability of occurring type 1 error is denoted as alpha. Probability of occurring type 1 error is equal alpha. Type 1 error the probability that is called alpha. Probability alpha is probability of occurring type 1 error. Alpha type 1 error. So what is that? Probability of H not rejected when it is true. H not rejected when it is true. H not rejected when it is true. When it is true. This is your probability of type 1 error. So what is your type 2 error? Type 2 error. Type 2 error is not rejecting null hypothesis. So H naught using the sample details. Once H naught is not true, is accordance with the particular details. So then probability of occurring type 2 error is denoted by beta. Type 2 error beta. What is that? So then not rejecting null hypothesis when it is not true. Again, null hypothesis So then that is called beta is probability of type 2 error. Type 2 error. So then H naught not rejected. When it is not true. When it is not true. These are the two types of errors. So that is type 2 error. Right. There are two types of errors are there. So then what will happen? Alpha and beta. So then now what will happen? So then our null hypothesis is success. Sorry, the hypothesis testing is success. So then error terms to be minimizing. Errors cannot be make them as 0. Make a bindu but we can minimize it. So then our hypothesis testing is success and then our conclusions are more accurate. So but what will happen? The both errors cannot be minimizing together. Errors So then there are two types of errors are there. So really in case of hypothesis testing, what we are going to do, we make one error as constant level. The other one is the minimizing as much as possible. Which one you are going to make as constant? So we make alpha as constant. Alpha type 1 error so we minimize the type 2 error. That is the most to get a more success results, the most accurate results. So then we fixed our type 1 error as a fixed level. So So then that level is less than like 5%, 10%, 10ට වගේ අඩු. ඒ කියන්නේ like what in our confidence intervals, so we make our confidence level is always more than 90. සාමාන්‍යයෙන් 90ට වඩා වැඩි probability එකකින් තමයි අපි හැමතිස්සෙම අපේ confidence level එක ගන්නෙ. ඒ වගේම මේකට අපි කියනවා that is called significance level. Alpha is called significance level. වෙසසි මට්ටම කියලා කියනවා සිංහලෙන්. ඒතකොට මේ alpha කියන එක, so we make at least so වැඩිම ගාන තමයි 10% වගේ එකක්. 5%, 2%, 1%. So then we make. So then we fix them as the very small the percentage. හුඟක් වෙලාවට 105ට වඩා අඩු. සමහරවිට 10% වගේ ගන්නවා. So 10%, 5%, 2%, 1% like that. So we fix them and minimizing our type 2 error. Type 2 error එක තමයි අපි minimize කරන්නේ. So that is the type 2 error is beta. So then what do you call 1 minus beta? That is called power of test. අපි ඒකට කියනවා power of test කියලා. When the probability of type 2 error, so then beta is minimizing, the probability of not occurring type 2 error is maximizing. That is 1 minus beta is known as power of test. So අපි ඒකට කියනවා 1 minus beta power of test. Power of test is 1 minus beta power of test. Power of not occurring type 2 error. 1 minus beta. What is that? Power of test is equal 1 minus beta is equal power of test. No, not occurring type 2 error. Not occurring type 2 error. Not occurring type 2 error is what? So then probability of rejecting null hypothesis when it is not true. It's not rejected. It's not rejected when it is not true. When it is not true. Right. So then we are not speaking about 1 minus alpha. 1 minus alpha ගැන කතා කරන්න දෙයක් නෑ. alpha දීලා තිනවා. Alpha is fixed. So then 1 minus alpha is the other side. එතකොට 1 minus alpha, so when we fix the alpha කියන එක අපි fix කළා. ඉඳා 1 minus alpha ගැන අපිට කතා කරන්න දෙයක් නෑ. So then 1 minus beta is our the power of test. So everything I summarized as a table. ඔයගොල්ලන් මෙන්න මේ table එක මතක තියාගත්තාම that's okay. ඒක තමයි ලේසිම විදිය. මොකද්ද මේ දීලා තියෙන්නේ? Decision and then it is correct or wrong. What is that decision? මේ table එක මතක තියාගන්න. So then keep in your mind. So then that is everything is summarized as. So then I have given that table. මම මේක දීලා තියෙනවා decision. මේ table එක මතක තියාගන්න. ඒකෝට ඔයගොල්ලන්ට එකක්වත් වරදින්නේ නැහැ. Decision. එතකොට H naught is true, probability. Probability. H naught is true, H naught is not true. H naught rejected and H naught rejected. එතකොට සමහර වෙලාවට කෙනෙක් වගේ අහන්න පුළුවන් ඇයි මේ හැම එකම H naught එකට බේස් කරන්නේ. So in our testing hypothesis, our first step is by making the two statements. So what is your H naught? H naught කියන්නේ null hypothesis එක. So then we assume that that is temporary true. අපි සාමාන්‍ය null hypothesis එක කියන්නේ කියන එක අපි తాවකාලිකව හරි කියලා කියන එකනේ. So one say that the lifetime of an electric bulb is at least 2500 hours. අපි ඒක හරි කියලා උපකල්පනය කරලා ඒක වැරදුනොත් කියන එක තමයි that is your alternative hypothesis. ඒ හින්දා තමයි all decisions based on H naught. H naught කියන එක තමයි based on our claim. ඒ කියලා තියෙන කල්පිතේ ඒ හරි කියලා අපි කියන්නේ අපිට හොයන්න ඕන එක තමයි අපි හැමතිස්සෙම H naught කියලා දාලා දෙන්නේ. ඒ හින්දා so all decisions we make based with H naught. නැත්නම් දැන් කෙනෙක් අහන්න පුළුවන් why H naught H1 is not there. Right. So then what is this one? How you do this? How you fill this one table? So then H naught is true when H naught is really true, that is rejected. That is alpha. මේ තියෙන alpha. ඒ කියන්නේ ඇත්තටම හරි වෙලාවෙදී අපි එක මේ alpha කියන එක අපි එක reject කරනවා. So that is called alpha. So then type 1 error. This is a wrong decision. මේ වැරදි නිගමනයක්. Wrong decision error එක. What is that? Type 1 error. That is called type 1 error. Type 1 error. That is called type 1 error. H naught is rejected, H naught is not true. H naught is rejected, H naught is not true. 1 minus beta, 1 minus beta. H naught is rejected when it is not true. That is 1 minus beta. That is correct decision. 1 minus beta can correct decision. So what is that? That is called power of test. That is called power of test. That is called power of test. H naught is not rejected. H naught is true. H naught is true. H naught is not rejected. That is 1 minus alpha. Make alpha now 1 minus alpha. Do not have any. That is the decision is correct. Nigamane hari 1 minus alpha. Decision is correct. So then no any special name for that. මොකක්වත් ඒකට විශේෂ නමක් කියන්නේ. H naught is not rejected. H naught is not true. That is beta. That is beta is type 2 error. Beta is type 2 error. So wrong decision. Type 2 error. It is type 2 error. Wrong decision. Decision is wrong. So now this is your summary table. So then you all have an idea what is alpha, beta and 1 minus alpha. Alpha, beta and 1 minus alpha. That is the first thing. But what about type 1 and type 2 error? Papers what is that type 1 error? What is type 2 error? What is power of test? This summary, so you can make them as a paragraph. That's okay. Now the alpha, beta and 1 minus beta. Type 1 error, type 2 error and power of test. Right. Then test statistic. Single පරීක්ෂණ සංඛ්‍යාතිය. Test statistic සිංහල වචනේ තමයි පරීක්ෂණ සංඛ්‍යාතිය. එතකොට අපි කොහොමද මේක so how we do that? So now here how we are going to find the one claim is hypothesis is true or false. අපේ මේ දීලා තියෙන ප්‍රකාශනයේ සත්‍යද අසත්‍යද කියලා අපි බලන්න යන්නේ කොහොමද? Based on the sample data. Sample from that particular population, we have taken the representative sample by using more suitable sampling technique. Population sampling sample technique. We have drawn a sample and then we calculate. Now let's say you are going to testing hypothesis, that is your statement is regarding population mean mu. Population mean mu mean lifetime of an electric bulb is at least $2,500. So we draw a sample from that particular factory and then we calculate the mean, standard deviation and the size of sample. So then විදුලි පුපුරු නිෂ්පාදකයා කියනවා එයාගේ කර්මාන්ත ශාලාවේ තියෙන විදුලි පුපුරු වල අවම ආයු කාලය 2500ක්වත් වෙනවා. ඒතර අපි එකකින් කලෙක්ට් කරනවා. මේ data අපි ගත්තොත් එහෙම sample with size 100 or whatever. මොකක් හරි sample එකක් අරගෙන ඒකෙත් අපි calculate කරනවා mean, standard deviation and sample size. Sample size එක අපි අනිවාර්යෙන් යදගත් වෙනවා. And then what will happen? So then our sampling distributions, we learn about sampling distributions. Sampling distributions can have it has the special properties. So then what will happen? They are following a normal distribution or T distribution. That follows a normal distribution. Follows a T distribution. So we can summarize them values, the sample figures as a single Z value or T value. So then we summarize those data as a single number. So then that may be lesson. So it may be a Z value or T value. Why? It follows the normal or T distribution. So that is called test statistic. Test statistic. In order to determine whether the accept the null hypothesis or not, the statistic computed using the sample elements is called test statistic. So that may be the Z value or T value. Test statistic. Critical region. Critical region. Critical value. Critical value. That is the boundary value. Boundary value. So what we are going to do? So as I told you that probability of type 1 error, we fix them as alpha. Type 1 error fix. So then we are going to minimizing type 2 error. Type 2 error එක තමයි අපි minimize කරන්නේ. මොකද both errors cannot be minimized together. දෙකම එක සැරේ අපිට අඩු කරන්න බැරි හින්දා. ඒතකොට අපි fix කරන එක තමයි alpha. ඒතකොට alpha should be given. Alpha should be given under 5% significance level. Like your the confidence intervals. Create 95% confidence interval, 99% confidence interval කියනකොට see whether your mics are muted. Mics mute කළා කියලා. So then in case of confidence intervals, so they have given one particular probability level 95% කිව්වහම, so then assume that it is a normal distribution. You know what is the table value according to that. There is one technique. So then if it is a t distribution, so then you know what is the t value of about that. Like that. So this critical value we computed by using our alpha. Alpha dunnahama. So then there is a technique of getting whether the z value or t value. So that is called the critical value. අපි ඒකට කියනවා critical value කියලා boundary value එක. එතකොට අපි let's say your sampling distribution is a normal distribution, the critical value. මෙන්න මේක. So we can compute by using our alpha. මෙන්න මේක ගන්න පුළුවන් alpha. සමහරවිට මේක පැති දෙකට මේ ඉලක්කමක් එනවා. ඕ මේක පැත්තකට එනවා. කොහොම හරි any value can be computed. So then the value of the boundary where the acceptance region and rejection region are positioned as at any given level of significance is called critical value. To determine the critical value, the sampling distribution. So then you needed whether sampling distribution is either t distribution or normal distribution. The size of the test, that is alpha. Alpha කියන එකක් ඕන වෙනවා. The critical region should have been known. එන්නේ ටික base කරගෙන තමයි අපි මෙතන. So then based on now, දැන් අපි හිතමු based on alpha and sampling distribution, so we just find out some value, that is the boundary value. එතකොට මේ boundary value, let's say you have this value as 1.96. Our test statistic has 2. So then it goes to this colored region is critical region. එතකොට අපේ test statistic එකෙන් ආව නම් calculate කරපු value එක 2 කියලා, it goes to rejection region. So it is like 1.8, it goes to acceptance region. White color area is acceptance region. And ඒකෙන් තමයි අපි හැම වෙලේම, so we see whether our null hypothesis is accepted or rejected. ඒකෙන් තමයි බලාගන්නේ based. So we calculate boundary value based on alpha, and then we calculate another z value. So then by using the test statistic, so then by comparing them. එතකොට මේකෙන් මේ පැත්තටද මේ පැත්තට. So then see whether it goes to the rejection or acceptance region. That boundary value is called critical value. So the main part to evaluate the critical value is alpha. Alpha කියන එක දෙන්න ඕනේ. Alpha should be given. Right. So the directions of locating critical region. Critical region එක මේ අඳින විදිය. So then that is based on the type of alternative hypothesis. Alternative hypothesis එකේ විදියට තමයි. So we have to mark. සමහර වෙලාවට so we mark 2 critical regions. So sometimes we have only one critical region. So then based on that we mark our critical region. So then now how we locate the critical regions is given these 3 diagrams. මෙන්න මේ diagrams තුනේ දීලා තියෙනවා how we locate the correct critical region based on the alternative hypothesis. Alternative hypothesis එකෙන් තමයි. So then we decide, so which there are 3 diagrams are there, which diagram to be used. කොයි එකද අපි පාවිච්චි කරන්න කියලා. හරි. So directions of locating a critical region. මේක හොඳට තේරුම් ගන්න. ඊට පස්සේ පුළුවන් any question given from this hypothesis part you can answer it. So then once you know this theory, so then the directions of the critical region, locating critical region. Critical regions කියලා දාන්න කොහොමද? Right. So then any test is given. So once we mark H0 is equal mu and H1 is less than mu. H1 is less than mu. H0 is mu, H1 is less than mu. H0 is mu. So then they ask you to make under alpha significance level. Make a 5%, 10%, 2% like that. This is like, so then the electric bulb manufacturer says that. So then the average lifetime of this electric bulb is at least 2,500. At least 2,500 2,500 or above is the value. If it is less than, only rejected. Under 5% alpha significance level. How we mark our critical region? So we locate our critical region on left edge of our sampling distribution. Assume that it is let's say normal distribution. එතකොට මේ alpha කියන එක අපි වම් පැත්තෙන් සම්පූර්ණව ලකුණු කරමු. So this is alpha. 5% නම් මෙතනින් 5% area එකක් වම් පැත්තෙන් ලකුණු කරමු. So this is our critical value. This is our critical value. So then now this is alpha. Alpha is on left edge. Left edge එකකින් alpha. Alpha. This kind of test is we could call one tail test. एक critical region එකයි තියෙන්නේ. So under one tail category we call them as a left tail test. One පැත්තෙන් ලකුණු කරන්නේ. Under one tail category it is a left tail test. Left tail test. Then what is your example 2? So then there may be some questions. So then your null hypothesis. H naught mu is H naught is equal mu. H naught is equal mu. H naught mu is equal to H naught mu less than theta. It was it. So then there may be some questions. H naught mu is equal to theta. H naught greater than theta. Let's say defective percentage. Defective percentage of the lot of goods is. So then the maximum defective percentage is the 5%. 5%. Again, lot maximum defective percentage is 5%. So defective percentage of 5% or less is valid. So if it is the greater than 5%, that's the rejected. Raw material, the lot of raw material has its defective percentage is 5%. See at a high defective percentage. So then 5% or less, maximum defective percentage is 5%. එතකොට වැඩිම තියෙන පුළුවන් දෝෂ ප්‍රතිශතය 5%. එහෙමනම් 100%ට ඒ කියන්නේ 100%ට අඩු වුණාට කමක් නැහැ. එතකොට 100%ට වැඩි වුණොත් තමයි it goes to be rejected. Once again, the one tail test. One tail test on, but you have to mark your rejection area and alpha significance level. And alpha significance level. And alpha significance level. So they should be given. So then what you are going to do? So your critical region, you mark on right edge of your distribution. Whole alpha goes to right edge. It's going to make 5% now. The one tail category, right tail test. One tail category, right tail test. One tail test, but it is right tail. The alpha is there. Alpha is on right edge. Alpha. Right edge area is alpha. So then this kind of hypothesis test. This kind of hypothesis test. Again, one tail category. So then on right tail test. One tail category, left tail test. And one tail category, right tail test. So then what about the other one? So there may be exactly. So then chemical content of a particular, let's say drug, the chemical one component A. So with 5 milligrams, exactly 5 milligrams. A base වර්ගයේ තියෙන A කියන chemical එක තියෙන්නේ මිලිග්‍රෑම් 5ක් විතරයි. ඒක මිලිග්‍රෑම් 5ට වඩා වැඩි වුණායි කියලා drug එක හොඳ වෙන්නේ නැහැ. අඩු වුණායි කියලා drug එක හොඳ වෙන්නේ නැහැ. It should be exactly the 5 milligrams. හරියටම මිලිග්‍රෑම් 5යි. So then if it is greater than or less than, both are so rejected. ඒ කියන්නේ මිලිග්‍රෑම් 5ට වඩා වැඩි වෙන්නත් බෑ අඩු වෙන්නත් බෑ. එන්නොත් මේ drug එක ඒ standard එකේ නැහැ. So then which kind of test is there? So our statements are mu is equal theta. හරියට මේ ගාන and H naught mu not equal theta. ඒක එකට වඩා වැඩි වුණත් වැරදි අඩු වුණත් වැරදි. And alpha significance level. And alpha significance level. So what will happen? Now you have two critical regions. එතකොට areas දෙකක් වෙනවා. Why? If it is greater than 5 milligrams or less than 5 milligrams, both sides are rejected. එතකොට අපි මොකද කරන්නේ? So your sampling distribution. So your sampling distribution, both are, so either sides. So we are marking our rejection regions. දෙපැත්තෙම mark කරනවා but each has alpha over 2. එතකොට මේ පැත්තේ alpha over 2 100ට 5 නම් 102.5ක් මේ පැත්තේ 102.5ක් මේ පැත්තේ. Two tail tests. So this one is not equal කියන ඒවට අපි කියනවා two tail test. Two tail test. So then now this is the method of locating your rejection regions by looking at the alternative hypothesis. මේ alternative hypothesis එක දිහා බලලා තමයි අපි මේ rejection region එක locate කරන්නේ. So then with the significance level. Not equal කිව්වොත් අපි critical regions දෙකක් mark කරනවා with each side with alpha over 2. 105 කිව්වොත් මේ පැත්තේ 2.5යි මේ පැත්තේ 2.5යි. So then once again the same thing I explained the one tail and two tail tests. මේ තියෙන එක ආපහු සැරයක් මම දාලා ඒ දෙකම මම එකට explain කරේ. So if the value pointed by the alternative hypothesis are located in a single direction of the values given by the null hypothesis, the hypothesis test launched with that regard are called the tests are as two types, left tail test and right tail test. Maybe in left tail test, now this is our right tail test. So then same diagram I have drawn here. බලන්න මම ඇදලා තියෙනවා ඒ diagram එකම. Then what about your two tail test? Two tail test, if the values pointed by the alternative hypothesis are located either side of the value of the null hypothesis, the test launched with this regard is known as two tail test. Okay? Two tail test. With not equal given by alpha over two tail tests. Two tail tests. It was then there is one worked example is there. Worked example is there. Right. Before that, now you all understood those theories. One tail test, type 1 error, type 2 error. So what is our one tail, two tail test? එටික තේරුණාද? Are you okay with that? එටික තේරුණාද? Are there any questions? මොනවාරි තේරෙන්නේ නැති එකක් තියෙනවද? The process about the hypothesis testing. තේරුණාද ඒ ටික? ළමයි තේරුණාද? Yes or no? Are there any questions? කියන්න තේරුණාද නැද්ද කියලා. මට පොඩක් කියනවාද ඔයාලගේ මැසේජ් මට පේන්නේ නැහැ මම මේ ෆෝන් එක ගහලා තියෙන තැනින්ද මේ මොකද මේ ඕක එහාට මෙහාට වුණොත් බෝඩ් එක පේන්නේ නැතු වෙනවා ඔයගලන්ට. ඔය මැසේජ් my connection තා මොනවා හරි ඔයගලන්ට තියෙනවද? ගැටලු තියෙනවද? Are there any questions? chats බලන්න පේන්නේ නැහැ මට. Shall I move to the next part? ඊළඟ එකට යන්නද? මේ වෙනස් වුණොත් එහෙම මේ මට මේ ෆෝන් එක ආයි බෝඩ් එක ඔයගලන්ට පේන්නේ නැති වෙනවා. අහන්නකො මොකක් හරි තියෙනවද? මොනවද තියෙනවනම් අහන්න. Sorry, අහන්න.
Can you explain errors? Hello?
Yeah.
Hello?
Explain which one? Errors.
Errors. Oh,
Errors. Type 1 error and type 2 error. So you need
Yeah.
that?
yeah.
Yeah. So in English, you are an English medium student.
Yes.
So anyhow, so I have to explain in English. English වලින් කියන්න ඕනේ සිංහලෙන් නෙමෙයි වල තේරෙන්නේ නැහැ නේද? සිංහල දන්නේ එක්කෙනෙක්ද නැති එක්කෙනෙක්ද කියනකො? Are you in non-Sinhalese student?
Yeah.
Sinhalese දන්නවනම් yeah, right. So what will happen? Really, so then now why our testing hypothesis procedure, what we are going to do? So we are going to confirm the statement regarding a population parameter. However, so one person says that. So then average lifetime of the electric bulbs manufactured by his company is at least 2,500 hours. So he says that. So that statement is regarding the population parameter. Population parameter. So you are going to see whether that manufacturer's claim is true or false. So then we are going to conducting a test. So how we conducting a test? So then by the drawn a sample from that particular population. By dealing with populations is not easy. So therefore, we drawn a sample. So then we have drawn a sample. So then from our population, and then we calculate. Now this is the statement regarding population mean mu. So then we calculate the sample mean, sample standard deviation, and then some measurements based on that. So really, so then we just drawn a sample is the most suitable sampling technique. So anyhow, but population is not the 100%, sample is not equivalent to the 100%, not equivalent to the population. So then population and a sample are, so the two different things. So there may be the measurements based on a population and the measurement based on a sample has very small differences. That is called sampling errors. So therefore, there may be, because of that. So then we make all these decisions based on a sample. So then two types of errors may be occurred. So that is called, one type of error is type 1 error and the one type of error is type 2 error. What is your type 1 error? Type 1 error is like, so then your null hypothesis, the manufacturer's claim is exactly true, but our testing process gives us it has been rejected. So then the null hypothesis is actually true, but it is rejected. That is called type 1 error. So in the real life situation, it is like that. It's like what? So that a lot of students who studied hard, so can get very good results. So that once you studied the more and more hours, studied hard. So then all 100% of students, so who are studying hard can get the very good results. No, very small percentage is there. Unfortunately, they can't go through the examination. Type 1 error. So then they studied hard and hard. So then what will happen? I don't know what is the, maybe based on one particular reason, so they can't go through the examination. Right? So then what else? The other side is, so then your null hypothesis is not true. Null hypothesis is varadi. But your testing process gives that it is not it should be accepted. It is not rejected. So then really it is false. So then it is not rejected. Type 2 error. That is called type 2 error. So it is like what? So then some students, they are not studying. But anyhow, so then they luck by chance, they got through the examination. Type 2 error. Type 1 error and type 2 error are like that. So then the probability of occurring type 1 error is called as alpha. Probability of occurring type 2 error is known as beta. So then in testing procedure, both errors cannot be minimizing together. So there is a rule. We fixed our type 1 error and minimizing type 2 error only. So then once you minimizing type 2 error as much as possible, that is called power of test. That is 1 minus beta. So then go through that note and then, so then you learn what is alpha, beta and 1 minus beta and look at that summary table. Okay? Understood? Terunadde? Student who asked me a question. Terunadde? Are you okay with that?
Yes, madam.
Yes, right. Right. So now there is one worked example. We make it. So then now we in our section 2.7 now we are repeating once again. So now we turn to 2.7 section, that is the conducting hypothesis test about the various sampling distributions. Now here, now we are conducting hypothesis testings about the population mean mu. So then that is regarding the population parameter mu or population proportion pi. Difference between two means and difference between two proportions. Again, various types of sampling distributions. There are 4 types of sampling distributions, but your CAT exam, they are going to test your knowledge about population mean mu. Testing area ke mu එක විතරයි තියෙන්නේ. So now we'll study about that now. 2.7, section 2.7. So now I'll send the note to you. So then to one of the students. So, so can you distribute them to others? කවුරු හරි කෙනෙක් just put I have few numbers, so then drop me a message එකක් දාන්න මගේ number එකට, so then I'll send the note to that the you. පොඩ්ඩක් මට විනාඩි 5ක් දෙන්න, give me 5 minutes, I'll send the note to you. මම note එක එවන්නම් 2.7 එක. Give me 5 minutes. I send the note to 2 students. Have you got it? ළමයි දෙන්නෙකුට මං එව්ව හම්බුණාද note එක? Can you distribute them among others? I don't know whether are you present. Got it? Send the note to 2 students. හම්බුණාද කාට හරි note එක? 2.7. Got it? Still not. So then I sent to 2 students who placed message earlier. මං කාට හරි මට message එකක් දාන්න කිව්වට දැම්මේ නැහැ නේ කවුරක්වත්. Put a message to me. I don't know those students are present today. කවුරු හරි කෙනෙක් දාන්න මට message එකක්. I'll send to them. Drop me a message. Students who present today, drop me a message. Do you have my number? Drop me a message. Right, right. I'll send it. Okay. Right. I think it's okay. Avane. So then distribute them to others. Anitha Danda. $2.7. Right. Right. Once again, the 2.7. So then send the note through others. So now this is testing hypothesis regarding population mean mu. So with various sampling distributions, everything is there. So that is the difference between two sampling means X bar and sampling proportion and difference between two sample proportions. So then huge note. So now the CAT exam, the testing areas, they ask you to, so the testing hypothesis only about the population mean mu. ඒක විතරයි අහනවා කියලා දාලා තියෙන්නේ. Just now we complete that section, right? Conducting hypothesis tests without tests about various sampling distributions. Testing hypothesis about population mean. That's what you need now. The testing hypothesis about population mean. So then an opinion about the unknown population mean is known as hypothesis regarding population mean. Now this is the hypothesis statement is hypothesized statement is the regarding the state is a statement regarding population mean mu. So then like what some examples are there. A firm involved in manufacturing nuts states that the average diameter of nut they produce is 5 millimeters. එතකොට nut එක the diameter එක millimeter 5 කියලා කියනවා. A firm involved in manufacturing kids chairs states that the maximum height of chair manufactured by them is not more than 45 centimeters. එතකොට පොඩි අයගේ පුටුවක පරිමෞස 45 centimeters, not more than 45 centimeters. 45 or less is the valid, greater than 45 is invalid. So then the previous one, exactly 5 millimeters, the diameter of the nut. The manager of a company states that daily average sales has exceeded 200 units that existed prior to the launch, the new advertising campaign. The manager of a company states that daily average sales has exceeded 200 units. එතකොට තිබිලා තියෙන 200යි ඊට වඩා වැඩි වුණා that existed prior to the launch the new advertising campaign. එතකොට advertising campaign එකෙන් පස්සේ ඒක 200ට වඩා වැඩි ඉහළ ගියා කියලා තමයි කියන්නේ. So now these are each of the three statements mentioned above comes out with an opinion regarding the mean of population. So then all these are the population mean, statements regarding population mean. So then the facts whether these opinions presented are true or false can be determined based on evidence revealed through a sample data. For that purpose, hypothesis test be tested using an appropriate level of significance. An opinion about unknown population mean can be tested under following cases. Once again, so can you remember in the case of the testing the confidence intervals? So then regarding population mean mu. So then there are 5 cases we studied. So that is based on a type of a population. So then population is normally or non-normally distributed. Population variance is known or unknown. So then we known about the sampling distribution. Again, we are conducting hypothesis tests regarding all 5 cases. මේකෙදිත් අපි cases පහම ගන්නවා, which kind of population, the variance is known or unknown. So here we need, so in the case of confidence interval, there is a separate equation. The population parameter is equal sample statistic plus or minus table value into standard error. අපි එතෙන්දී equation එක තමයි සමහර වෙලාවට standard error may be S over root 10. It is a normal distribution. Sigma over root 10. Sometimes it is a T distribution likewise. මෙතෙන්දී අපිට වැදගත් වෙන්නේ in case of the hypothesis testing, what is our test statistic? Whether if it is a Z value or T value. Z the T the කියන එක තමයි මෙතෙන්දී අපිට ඕන වෙන්නේ. All together the same the 5 cases are there. Same 5 cases are there. An opinion about unknown population mean can be tested under following cases. Case number 1. Case number 1. Case number 1. So what is your case 1? Population is normally distributed. Population variance is known for any size of sample. For any size of sample. Case 1. So what is your sampling distribution of sample means? Under case 1, case number 1, sampling distribution of sample means are normally distributed with population mean mu and what is the variance? Sigma square over A. So now here the important part is that, so now your test statistic is Z value. Z value, now this one follows a normal distribution. Z is equal x bar minus mu sigma over root 10. Sigma over root 10. Now this is your case 1. What are the conditions? Population is normally distributed. Population variance is known for any size of sample. So what about your case 2? The case 2. Case 2 is population is normally distributed. Case 2. Case 2. Population is normally distributed. Population variance is unknown and for large samples. For large samples. So what is your sampling distribution of sample means? X bar is normally distributed with population mean mu. What is your variance? S square over A. Sample variance divided by sample size. If our population variance is unknown, so we replace the term by using sample variance. Sample variance. Once again, it follows a normal distribution. What is your test statistics? X bar minus mu S over root 10. S over root 10. That is your case 2. That is your case 2. Population is normally distributed. Population variance is unknown for large samples. For large samples, this is your case 2. So what about your case 3? Case 3. Case 3. Population is normally distributed. Population is normally distributed. Population variance is unknown for small samples. For small samples, population is normally distributed. Population variance is unknown for small samples. What will happen? Your sampling distribution of sample means does not follow the normal distribution. It follows a distribution which is known as T distribution. So X bar is follows a T distribution with mean mu and variance S square over A. Now what is your said that test statistic now? It is a T value. A T value become X bar minus mu S over root 10. Now this is your case 3. Your case 3 is not a normal distribution. Case 3 is the sampling distribution is not a normal distribution. It follows a T distribution. Your test statistics now X bar minus mu S over root 10. X bar minus mu S over root 10. So what about your case 4? Case 4 is the case 4 and case 5 regarding what? Case 4 and case 5 regarding the populations are not normal. The population is not normally distributed. Case 4, the population variance is known for large samples. For large samples. Case number 4. Case number 4. Case number 4. Case number 4. Populations are not normally distributed. Population variance is known for large samples. What is that? The sampling distribution of sample means are approximately normally distributed. Approximately normally distributed with mean mu and variance sigma square over N. Now here this is approximately normally distributed. Approximately normally distributed. Even if it is approximately normally distributed, your test statistic is once again Z. So X bar minus mu sigma over root 10. X bar minus mu sigma over root 10. Only thing it is approximately normally distributed according to the central limit theorem. According to the central limit theorem. What about your case 5? Again, population is not normally distributed. Population variance is unknown for large samples. Case number 5. Case number 5. Case number 5. Population is not normally distributed. So then the population variance is unknown. So then for large samples. Sampling distribution of sample means are approximately normally distributed with population mean mu. What is your variance? S square over N. So once again it is the approximately. This is approximately normally distributed. Once again it is Z. Z is equal x bar minus mu S over root 10. S over root 10. Now these are the 5 different cases for you. So then case number 3 is the T distribution, and all other 4 cases are the normal distributions. So sometimes it is the approximately or anyhow normally distributed. So your test statistic in case number 1, case number 2, case number 4 and case number 5 all are normal distributions. The only case 3, so we have a T distribution. So then what are the conditions? So when we then even as our the confidence intervals, confidence intervals so then once you have drawn a small sample එකක් ගත්තොත් තමයි we have to verify them whether if it is a T or normal distribution. මොකද case number 1 එකේ තියෙන්නේ for any size of sample. How you verify whether it is Z or T? So now look at the standard deviation or variance. If they have given the population standard deviation, that is under case 1. Sample standard deviation, that is under case 3. අනිත් ඒවා නම් නැතිවත් කමක් නැහැ, ඕලා same. Population එක normal ද non-normal ද කියලා දුන්නේ නැතිවට කමක් නැහැ. So then once you draw a small sample, so then keep in your mind to select whether if it is from case 3 or case 1. Or the small sample එකක් case 1 එකටත් valid for any size of sample. For any size of sample. ඒක අපි verify කරගන්නේ. You have to verify whether if population variance is given, it is under case 1. Sample variance is given, it is under case 3. Case 3 now, so you have to follow your T distribution. So that is the thing. That is the important point. Once you have drawn a small sample එකක් ගත්තොත් තමයි අනිත් ඒවා නම්. So but you need to have an idea whether if it is S over root 10 or sigma over root 10. ඒක හොඳට ගාන කියවලා. So write your correct test statistic. S තියෙන එකට is sigma ලියන්න එපා. So then confirm it. Right, now we'll see by taking all together how to conduct the hypothesis test about population mean mu. Population mean mu. Right. There are 3 different worked examples. මෙතන මම worked examples තුනක් දාලා තියෙනවා. So go through it and so very carefully, and so this is the part they are going to testing in your CAT exam. අනිත් ටික අපි බලමු. අපි ඉස්සෙල්ලා මේ ටික හොඳට කරමු. So worked example 1. Heights of students in grade 13 are distributed normally with a standard deviation of 5 centimeters. So the heights of students in grade 13 are distributed normally. So then your population is a normally distributed one. So comes under either case number 1, 2 or 3. So with the standard deviation of 5 centimeters, population standard deviation is given in a particular area. A student states that average height of a student in grade 13 in this area is 162 centimeters. So then he states that the average height of the student of that area is 162 centimeters. So a sample of 9 students are taken at random and evaluate mean height of them. It is found that to be 160 centimeters. Test this hypothesis by using 5% level of significance. Read the question very carefully and let me know it is you drawn a small sample. So then drawn a sample with 9 students. The population is normally distributed. Now let me know it is from case number 1 or case number 3. What is a small sample is drawn now. Case number 1 or case number 3. 1 the 3 the බලන්න ඔක කියවලා හොඳට. මොකද්ද දීලා තියෙන්නේ? Given that the standard deviation of population or sample. So let me know the answer. Case number 1 or case number 3. කොයි එකක්ද ඔය? Population is normally distributed කියලා තියෙනවා. Which case? 1 or 3? 1 the 3 ද කියලා කියන්න බලන්න. හොඳට බලන්න. Case 1 or case 3? Under which case? 1 2 3 4 5 is out. 1 or 3? 2 in that standard deviation is given with population or sample. Population එකේ දීලා තියෙනවා නම් case 1, sample එකේ දීලා තියෙනවා නම් case 3. What is that? පැහැදිලිවම තියෙනවා ඉතින්. හොඳට කියවන්න බලන්න ගන්න. Yes, case number 1. That is case number 1. The given that population standard deviation, exactly correct. It is under case number 1. Case number 1. So given that the standard deviation of population. So where about it? So then you have to, if it is a small sample එකක් නම් verify it is from normal or T distribution, right? Then again, look at your population parameter statement. So what they have given, the mean height of, so then the heights of students in grade 13 are distributed normally with the standard deviation of 5 centimeters. So then that is the population standard deviation is given. The student states that, so then read it very carefully, that average height of a student in grade 13 in this area is 162 centimeters. මොකද්ද කියන්නේ? ඒ area එකේ ඉන්න 13 වසරේ ශිෂ්‍යයෙක්ගේ උස සෙන්ටිමීටර් 162යි. මේකේ කියලා නෑ. So they at least or at most or whatever. ඒ කියන්නේ එයා කියන්නේ හරියටම 162යි. Exactly. මතක තිබුණා නම් at least 162 centimeters, at most 162 centimeters. So then your test becomes in other side. වෙන විදිහකට යන්නේ. එතන මෙයා කියන්නේ so it is about 162 centimeters. The student states that area එකේ ඉන්න 13 වසරේ ශිෂ්‍යයෙක්ගේ උස හරියටම සෙන්ටිමීටර් 162යි. So if it is exactly 162 centimeters, greater than and less than both sides are rejected. එයා කියන්නේ at least කියලාවත් at most කියලාවත් නෙමෙයිනේ. එයා කියන්නේ හරියටම 162යි කියලා. Then what will happen? The at least and at the, so then the greater than 162 and less than 162 both are rejected. එතකොට මේ දෙකම reject වෙලා. So how we write our two statements? That is the important point. So now we can check whether test this hypothesis by using 5% level of significance. Again, එයා කියන්නේ හරියටම 162යි කියලා. එතකොට 162කට වඩා වැඩි වුණත් වැරදි, අඩු වුණත් වැරදි. So we have to conduct which kind of test? One tail or two tail test. So we have to conduct a two tail test here. Why? So he says that it is exactly 162. So example number 1. Example number 1. The first step is you have to make the two hypothesis statements by read it very carefully. හොඳට ඒක කියවලා. So then you have to write the statements. So then your first step is build up hypothesis statements. Build up hypothesis statements. So H naught mu is equal 162. H naught mu is equal 162. H1 mu is not equal to 162. Not equal to 162. So after making the build up your hypothesis statements, so then you have to decide the type of test. How we decide the type of test? By looking at your alternative hypothesis. The second step, type of test. Type of test. So which kind of test you are going to be conducted? A two-tail test. If it is one tail, then you have to state whether left tail or right tail. Now this is two-tail test. So then this is two-tail test. Two-tail test under normal distribution. Why? Under case 1. Under case 1, this is your normal distribution. This is under case 1. Case 1 in the make a normal distribution. This is not the T distribution. You have taken a small sample, but this is under case 1 normal distribution. So then you have to find out the critical value. Critical value is a boundary value. So given that the alpha significance level. So then your third step is find out your critical value, boundary value, critical value. So how we decide about the critical value? Look at the given alpha and type of test and the distribution. So what are the facts you are conducting to make your critical value? What is the type of your sampling distribution? A normal distribution, T distribution. Alpha, the significance level and type of test, one tail or two tail. Now this is a two tail test under normal distribution, So then draw your sampling distribution, normal distribution, normal distribution. Alpha is 0.05, 5% significance level. Alpha is 0.05. Now here rejection area goes as alpha over 2. 0.025. Now this is a two-tail test. So then in two-tail test, so then given the significance level, divide by 2. So then mark that area on either side of your distribution. එතකොට two tail test එකකදී හැම වෙලේම alpha කියන එක දෙකෙන් බෙදලා ඒ area එක දෙපැත්තට ගානට mark කරන්න. So each area with a 0.025. Each area with 0.025. If it is the two tail test. So if it is one tail test, either left tail or so right tail, so you have to mark whole alpha on one side. එතකොට ඒකෙදී අපි alpha දෙකෙන් බෙදන්නේ නැහැ ඒක rejection region එකයි. So area of each edge is 0.025. Now these colored areas are rejection areas. Rejection area දෙපැත්තෙන් තියෙනවා. දෙපැත්තේ මෙන්න area එක 0.025. So what would be this blank area? So මේකේ දශම පහෙන් අඩු කරන්න blank area එක ගන්න. 0.5 minus 0.25, 0.4750. 0.4750. But done on a normal distribution, 0.4750. 0.4750. So your rejection area, each area is 0.025. So now your acceptance area, the white color area is your acceptance area. So then acceptance area with 0.4750. Now follow up your normal distribution. So then as area 0.4750. But normal distribution area 0.4750 with which value? What is the value? What is that? 1.96. What is your boundary value? Now here it is plus 1.96. This is minus 1.96. So then in a two-tail test, how with a normal distribution, how you follow up your table? So given significance level divide by 2. Significance level එක දෙපැත්තට බෙදලා ඒ area එක දෙපැත්තේ mark කරන්න. So each area of each edge with 0.025. එහෙනම් in a normal distribution 1/2 is 50%. එක පැත්තක් 150 මේක ඇවිල්ලා 0.4750. So then go through your normal distribution table and find out that respective value 1.96. That is 1.96. Your boundary value is 1.96, critical value. Right. Now then, what is our next step? Analyzing sample data. Then අපි sample data analyze කරලා තව ඉසෙට් එකක් ගමු. මේ තියෙන්නේ the standardized value based on our critical value. So now analyzing sample data. This follows a normal distribution. Analyzing sample data. Z is equal x bar minus mu sigma over root 10. This is under case 1. Z is equal x bar minus mu sigma over root 10. Everything is given. What is your x bar? X bar is given. They have tested a sample of 9 students. So mean is given as 160 centimeters. Mean is given as 160 centimeters. Standard deviation of a population is given 5 centimeters. Population standard deviation. The sample size is 9. N is equal 9. N is equal 9. Now calculate your Z value. Z is equal x bar 160. What is your mu? Mu is equal 162. Mu is equal 162. X bar එකයි mu එකයි. X bar කියන්නේ sample එකේ එක, mu කියන්නේ the testing the H naught එක. Mu is equal 162. Sigma is equal 5. N is equal 9. Right. Simplify this and get your Z value. Z is equal 160 minus 162. 160 minus මේක මාරු කරන්න එපා. X bar minus mu 5 over square root 9. 5 over square root 9. What is your Z value? Minus 2 divided by 5 over 3. Square root 9 can 3. එතකොට මේ 3 එක උඩට අරගෙන යන්න. So that is minus 2 into 3 over 5. Z is equal minus 6 over 5. That is minus 6 over 5. minus 1.2. Z is equal minus 1.2. Minus 1.2. Your boundary value is 1.96. What about that? So then your calculated Z value is 1.2. So what can you say about that? So your boundary is 1.96. Minus 1.96. Have to make it minus 1.2. Minus 1.2 means it goes to the acceptance area. Minus 1.2 can mean minus 1.96. Minus 1.2 can mean. So then now we can say that H naught lies into acceptance area, H naught accepted. So H naught lies into acceptance area, H naught accepted. H naught so accepted. H naught accepted. So then what is your conclusion? The student's claim is, so student's claim is correct. So under 5% level of significance, to get my conclusion, accept the statement made by the student that average height of grade 13 students in that area is 162 centimeters and 5% level of significance. සියයට පහක වෙසෙසි මට්ටමයට ඒ කියන්නේ මේක සමහර වෙලාවට so we maybe have one error so under 5% level සියයට පහක් විතර මේක වෙනස් වෙන්න වැරදි වෙන්න මේ ඉඩක් තියෙනවා so therefore write your conclusion is average height of මේක නම් පුළුවන් තරම් කෙටියෙන් කියන්න average height of grade 13 student of that area is average height of grade 13 student centimeters at 5% level of significance. 5% level of significance. So then what we have an average height is about, oh, students' claim is correct. Students' claim is correct at 5% level of significance. So that should be right. At 5% level of significance. Understood that? Understood the question? Are there any questions regarding example 1? Example 1 is okay. First, how to write these hypothesis statements, how to build up the statements. So then how to decide the type of test based on the alternative hypothesis. So then the calculation about a critical value, then analyzing sample data, So now you can decide. So then your calculated Z value goes to acceptance or rejection region. Boundary value we can that is minus 1.2. So then write your conclusion and write so then see whether H naught lies into which area, acceptance or rejection area. It was taking up if it is acceptance area, H naught accepted, otherwise it is rejected, and then based on that you can make your conclusion. You can make your conclusion. Now this is the testing hypothesis procedure of all types of sampling distributions regarding a population mean mu, proportion p, mu1 minus mu2, p1 minus p2, හැම එකටම යන්නේ the same process is goes. මේ විදිහටම තමයි යන්නේ, but so then there are small differences of your test statistic. ඒ ටික වෙන වෙනම මම දීලා තියෙනවා. This is the summary. So then all are. So then you have to identify it is under which case. කොයි එකද කියලා බැලුවා, බලලා ඉවර වෙලා. So you can understand well. Now the two more questions are there. ඒකත් හදලා. So then they will complete 2 exercises given here. So then you have expert about the testing hypothesis. ගණන් 5යි හදන්න ඕනේ. About population mean mu. මේකම තමයි continue වෙන්නේ. The same process for other kinds of sampling distributions. Right. Then look at your worked example 2. So worked example 2. A maximum weight borne by a steel wire is an average of at least 150 kilograms. A maximum weight borne by a steel wire in an average of at least 150 kilograms. එතකොට මේ කියන්නේ හඩ කම්බියකට දරන්න පුළුවන් උපරිම බර අඩුම ගානේ කිලෝග්‍රෑම් 150ක් කියලා කියනවා. At least 150 kilograms. A sample of size 64 was taken out and tested, and the maximum weight was 145 kilograms with a standard deviation of 16.8 kilograms. Test the hypothesis at 1% level of significance. Now read it once again. A maximum weight borne by a steel wire is an average of at least 150 kilograms. එතකොට ඒ කම්බියට දරන්න පුළුවන් උපරිම බර අඩුම වශයෙන් කිලෝග්‍රෑම් 150ක් වෙනවා. එතකොට 150ට වැඩියක් දරන්න පුළුවන් කියලා තමයි එකකින් කියන්නේ. Right? A sample of size 64 was taken. එතකොට මේකේ අරගෙන තියෙන large sample එකක්. එතකොට no worries about that. That's a sampling distribution with Z. Z එකක් තමයි මේ තියෙන්නේ. So taken and tested, and maximum weight was 145 kilograms with a standard deviation of 16.8. So here they have given the sample mean and sample standard deviation and a large sample. So then what will happen? This is not case number 1. Case number 1 එක නෙමෙයි. මේක හැබැයි කියලා නැහැ population is normally distributed or not. ඒක එච්චර වැදගත් වෙන්නේ නැහැ. This is not case number 1. And this is not case number 3. Case number 3 නෙමෙයි මේක. So 1 and 3 is out because why? The population, the variance is case number 3 නෙමෙයි වෙන්නේ. That's not a small sample. Case number 1 is not. Why it is that? So they're given the sample standard deviation. And again, case 4 is also out. Case 4 එකත් out වෙනවා. මොකද case 4 එකේ තියෙන්නේ the population standard deviation, population variance is known. So මේකේ population variance එක නෙමෙයි දීලා තියෙන්නේ, sample variance එක නැත්නම් sample standard deviation එක. This is either case 2 or case 5. Case 2 හරි case 5 හරි මේක. එතකොට මේක case 2 ද 5 ද කියලා අපිට verify කරන්න ඕනේ නැහැ. Both are the sampling distribution is normally distributed. If it is case 5, approximately normally distributed. Case 2 නම් හරියටම normally distributed. Anyhow, that is Z with S over root 10. හැබැයි ඔකට ලියන්න එපා sigma over root 10. Because why? So they have given the sample standard deviation. Case 1, case 3 and case 4 are out. So then why? Case 1 is out. That is not the population, the standard deviation. Population is normally distributed කියලා දීලා නැහැ. Case 3 එක වෙන්නත් බෑ, it's a large sample, and case 4 එක වෙන්නත් බෑ. So then the population variance is not given. ඒ හින්දා මේක වෙන්නේ either case 2 or case 5. දෙකම එකයි. So then your sampling distribution is Z. Right. Once again, go to the hypothesis statements. Right, builds up hypothesis statements. So what they say is that, so then the maximum height borne by a steel wire is at least 150 kilograms. At least 150 kilograms කියන්නේ so 150 or more is valid. 150ක් වෙන්නත් පුළුවන් ඊට වඩා වැඩි වෙන්නත් පුළුවන්. At least 150 kilograms, 150 or more is valid. So then normally we just write our hypothesis statement by using equal sign. අපි 150 කියලා කිව්වට මේකේ 150ට වැඩි වුණත් හරි. At least, the word at least is there. So therefore when it is rejected, if it is less than 150. එතකොට මේක කියපු එක වැරදෙන්නේ කොහොමද? මේකට බලන්න මේ ගම්බීර දරන්න පුළුවන් බර කිලෝග්‍රෑම් 150ට අඩුනා. When it is less than 150, so then the H note goes to be rejected. එතකොට H note reject වුණොත් reject වෙන්නේ 150ට වැඩි වුණාට reject වෙන්නේ නැහැනේ. එයා කියන්නේ at least 150. එහෙමනම් less than 150, so it goes to rejected. So write your H1, mu less than 150. Type of test, what is that? This is a one tail test. So under one tail test, so left tail category. One tail test. So that is left tail category, and this is again a normal distribution. Large sample under case 2 or case 5. 2 එකක් වෙන්නත් පුළුවන්, case 5 වෙන්නත් පුළුවන්. Case 2 or case 5. Right. How we find out now? This is a left tail test. So how we locate our critical region? Then කොයි පැත්තටද යන්නේ අපේ critical region or rejection region? On left edge of your sampling distribution. Sampling distribution follows a normal distribution. What is your alpha? Alpha 1% level of significance. Alpha is equal 0.01. Alpha is equal 0.01. So what you are going to do? So no need to divide alpha by 2. Alpha දෙකෙන් බෙදන්න ඕනේ නැහැ. This is one tail test and a left tail test. Left tail test කියලා කිව්වේ මොකෙන්ද? මෙතන H1 එක less than 150. බලන්න මම ඒව locate කරලා දෙන්න. Yes, and
මිස් එතකොට අපි දැන් අර දෙකින් බෙදලා ගන්න two tail test වලදී විතරද? අර
විතරයි. එතකොට නෑ one tail test එකේදී හැමතිස්සෙම alpha එක්ක වම් පැත්තට යනවා එක්ක දකුණට යනවා. වම් පැත්තට යන්නේ alternative එක less than නම්. Alternative එක greater than නම් තමයි යන්නේ ඒක දකුණු පැත්තට. දැන් මේක left tail test එකක්නේ. one tail test එකේ left tail category එක. එතකොට මේකේ හැම වෙලේම critical region එක 1% යන්නේ වම් පැත්තට. වම් පැත්තෙන් තමයි 1% ලකුණු කරන්නේ. හැම වෙලේම එහෙමයි. two tail එකේදී rejection area දෙකක් එන්න වෙනවනේ. ඒ කියන්නේ ඒ තියෙන ගානට වඩා වැඩි වුණත් වැරදි අඩු වුණත් වැරදි. මොකද ඒක කියන්නේ හරියටම සමානයි කියලානේ ඒ ගානට. හරියටම සමානයි කියලා කවුරු හරි කියනවා නම් ඒ ගානට වඩා වැඩි වුණත් වැරදි අඩු වුණත් වැරදි. ඒකයි. දැන් මේක කියන්නේ at least 150 නේ. at least 150 කියන්නේ අපි සිංහලෙන් කිව්වොත් මොකද්ද? දරන්න පුළුවන් බර කිලෝග්‍රෑම් අඩුම ගාන කිලෝග්‍රෑම් 150යි. ඒතර 150ට වැඩි වුණාට ඒක වැරදෙන්නේ නැහැනේ. මේක වැරදෙන්නේ 150ට වඩා අඩු වුණොත් විතරයි. ඒකයි. හරිද? ක්ලියර්ද ඒක? තේරුණාද ඒක?
ඔව් මිස්. ඔව්. thank you.
හරි. හරි. ඔයගලන් සිංහලෙන් දන්න අය හොඳට සිංහලෙන් අහන්න මම උත්තර කියලා දෙන්නම්. So the non-Sinhalese students ask me in English. So we have to mark 1% on left edge. So we have to locate our rejection area on left edge. එතකොට මෙන්න මේ කැලේ 1%. So then the area of left edge is 1%. So what about this? This is the normal distribution. What about this white color area? White color area is this is 1%. 0.01 make us 4900. 4900. So follow up your normal distribution as area 0.4900. That is 2.33 minus. And I lifted again the critical value is minus 2.33. So then area of edge is 1%. The critical area 1%. Again 0.01 critical region. Critical region क्या rejection region के लिए बताऊँ. Rejection region का CAT का non-rejection region is 49%. तो what है 49%. The Z value follow up your normal distribution that is 2.33 minus. Make a tenda, one tenda minus. Right. Analyzing sample data follows the normal distribution once again. Under case 205, Z is equal x bar minus mu S over root 10. Sigma name SC is given. X bar is given 145 kilograms. We have taken a sample with 64. Mu is equal 150. Mu is equal 150. SC is given with a standard deviation with 16.8. 16.8. Sample size 64. Sample size is 64. Sample size is 64. Right. Calculate your Z value. Z is equal x bar 145 minus 150 divided by S 16.8 over square root 64. Square root 64. Then minus 5. Then minus 5 over 16.8 divided by 8. Minus 5 into 8 over 16.8. Minus 40 over 16.8 minus 2.38 minus 2.38 minus 2.38. So that is minus 2.38. Z value is minus 2.38. What is your boundary value? Boundary value is minus 2.33. So what about your H naught now? 2.33 what make at the end. So H naught lies into rejection area. H naught rejected. They can 2.38 can it? That's colored area on rejection area. So H naught lies into rejection region. H naught rejected. H naught rejected. So H naught rejected means H1 accepted. H1 tamai thought accept karan. So what will happen? H naught rejected. So then what will happen? That manufacturer's claim goes to be low. Yeah, at least 150 kilograms came. So then what will happen? So we can say that the maximum weight borne by the steel wire is at least 150 kilograms is rejected at 1% level of significance. Write your conclusion. Write your conclusion. Maximum bearable weight of steel rods is at least 150 kilograms. Is rejected at 1% level of significance. One percent level of significance. 1% level of significance. So this is your conclusion. This is your conclusion. The same technique. එකම method එක කියන්නේ same technique. So you have to follow up. So write the correct statements. So then identifying the type of test based on H1. ඊට පස්සේ හරියට අඳුරගන්න critical value එක. ඊට පස්සේ analyzing sample data and see whether your calculated Z value goes to which area. කොයි පැත්තටද යන්නේ කියලා බලලා. So then write what will happen. So then based on that you can make your conclusion. එච්චරයි. ඕකම තමයි ඔය process එකම තමයි හැම එකටම යන්නේ. That is the main part. Population mean කිව්වත් ඕක difference between two means කිව්වත් ඕක ඔය විදිහටම තමයි යන්නේ. Right now this is example number 2. Example number 2. Example 3. අපි තුන්වෙනි එකටත් යන්. Example 3. So then you can understand well after making all 3 questions. Example number 3. Example number 3. The quantity of liquid contained in a bottle of soda is mentioned in its label as 200 milliliters. The quantity of liquid contained in a bottle of soda is mentioned in its label as 200 milliliters, but the customer claims that it is less than that amount. Less than that amount. එතකොට දැන් මේ ගහලා තියෙන මිලිලීටර් 200යි ඒ වුණාට මේ ඒක දැන් පාවිච්චි කරන කෙනෙක් කියනවා එතන 200ක් නැහැ කියලා. Less than that amount. Once a sample of 16 bottles were checked, the mean and the standard deviation have been computed as 199 milliliters and 2.5 milliliters respectively. එතකොට ඒක ටෙස්ට් කරන්න they have taken a sample with how many bottles? 16 bottles. බෝතල් 16ක් අරගෙන check කරපුවාම mean volume with 199 milliliters and so then with the standard deviation of 2.5 respectively. If the consumer's claim is acceptable and 5% level of significance, එතකොට මේ consumer එහෙම නැත්නම් පාරිභෝගිකයාගේ කියවන 5% වෙසිසි මට්ටමේ සත්‍යද කියලා අහනවා. Assume that quantity of liquid contained in the bottle may fall in a normal distribution. Now this is from a normal population. A normal population එකක්. So then case number 4 and 5 are out. The population is normally distributed with a small sample. Small sample, 16 bottles were checked. So now you verify it is from Z or T, case number 1 or case number 3. බලන්න මේක මොකක්ද කියලා? This is from which case? Number 1 or case 3. Population is normally distributed and you have drawn a small sample. Then standard deviation එක බලන්න. දීලා තියෙන්නේ sample standard deviation or population standard deviation. Now you verify it is from case number 1 or case number 3. කියන්න බලන්න මොකෙන්ද කියලා? Which case? 1 or 3? 1 the 3 ද?
Case 3.
Case 3. So why? The given that the sample standard deviation, 16 bottles were checked with mean 199 milliliters with a standard deviation. කීයක්ද මන්ද දීලා තියෙන standard deviation. So then sample standard deviation එක දීලා තියෙන හින්දා this is case number 3, a T distribution. Right. So, once again, build up the hypothesis state. T distribution එක ගන්න හැමෝම මේක T value එකක් තියෙන්නේ. T distribution එක බලන්න හැටි ඔයගොල්ලන්ට කියලා දෙන්න. Take out your t distribution. This is the t value. Take out your t distributions. So what will happen? Normally the volume contained in the bottle of soda is 200 milliliters. The 200 milliliters. But what will happen? The consumer claims that it is less than 200 milliliters. Now here the build up your two hypothesis statements is not with method 1. Method 1 එක නෙමෙයි method 2 එක. මොකද method 2 එකේදී වෙන්නේ මොකද්ද? අපි කියනවා ඒකේ ඇත්තටම තියෙන්න ඕනේ 200යි. හැබැයි අපි චෙක් කරපුවාම මොකක් හරි චෙක් කරපුවාම අපිට තියෙන්නේ ඊකට වඩා අඩු ගන්න 200ක් නෙමෙයි කියලා. ඒ කියන්නේ අර අපි සමහර වෙලාවට කියන්නේ අපි කියනවා මේ මොකක් හරි කම්පැනි එක ප්‍රොඩක්ෂන් මැනේජර් කියනවා ඒගොල්ලන්ගේ ඩේලි ප්‍රොඩක්ෂන් එක ඒකක 200යි. ඒකක 200යි. හැබැයි ඇඩ්වර්ටයිසිං සේල් එක අපි කියමු ඩේලි සේල්ස් ඒකක 200යි. හැබැයි ඇඩ්වර්ටයිසිං කැම්පේන් එකෙන් පස්සේ ඒක වැඩි වෙලා තියෙනවා. එතකොට is equal to 200 greater than 200. ඒ ඇඩ්වර්ටයිසිං කැම්පේන් එකෙන් පස්සේ ඒක 200ට වැඩි වෙලා තියෙනවා. ඒ වගේ මේකේ මේ තියෙන්න ඕනේ මිලිලීටර් 200යි. හැබැයි ඒක බලපුවාම consumer කියන්නේ පාරිභෝගිකයෙක් කියනවා 200ට අඩුයි කියලා. That is by conducting hypothesis statements by using method 2 by assume that alternative hypothesis is correct. එයා කෙලින්ම කියනවා ඒකට වඩා අඩුයිම කියලා කියනවා. ඒතකොට ඒක ගන්න alternative එකට අරක අපි සමානයි කියලා ලියනවා. So that is by method 2 build up the hypothesis statements in method 2. There are two methods. Temporarily assume that H naught is correct. අපි H naught එක සාමාන්‍යයෙන් මේ తాවකාලිකව සත්‍යයි කියලා අනිත් පැත්ත ලියනවා. ඒකේ තියෙන්නේ at least at most or හරියටම equal. So then like example number 1 or example number 2. Example number 1 එකේ කියනවා the average height is exactly 162. Example number 2 එකේ කියනවා at least 150 kilograms. මේකේ කියන්නේ මෙහෙමයි තියෙන්න ඕනේ 200යි. හැබැයි බලනකොට ඒක අඩු වෙලා. That is under method 2. So how we build up two statements? So H naught is equal to 100. H naught is equal to 100. Check කරපුවාම ඒක අඩු වෙලා. Less than 200. Less than 200. මේකත් හරියටම ලියා ගන්න ඕනේ. බලලා හැබැයි the most popular method is method 1. work වෙලාවට ඔයගොල්ලන්ට method 1 එකෙන් ගිහින් right. Then type of test. What is the type again? One tail test under left tail category once again. One tail test under left tail category. One tail test. So this is left tail. So what is the distribution? Now this is a T distribution. This is a T distribution under case 3. Under case 3. Under case 3. Right. To find out the critical value, now we have to follow up a T distribution. Then අපිට critical value එක බලන්න වෙන්නේ T distribution එකෙන්. So then again, any distribution. So then alpha is equal, what is alpha? Alpha is given under 5% level of significance. Alpha is equal 0.05. Then මොකද බලන්න මේකේ T එක නම් T distribution එක නම් what is your degree of freedom? Degree of freedom is n minus 1, 16 minus 1, 15. Make a degree of freedom to follow up a T distribution. Degree of freedom is n minus 1. Sample size is 16. 16 minus 1, that is 15. Again, mark 5% on left edge. Left edge again, 5% ලකුණු කරන්න. One tail test එකේ හැමතිස්සෙම මේ සම්පූර්ණම alpha එක පැත්තකට ලකුණු කරන්න. Now locate the critical region on left edge. Degree of freedom is 15. මේක 15යි. So how you follow up your T distribution? So then find out your T value. Degree of freedom 15. මේක 15යි. බිංදුවයි දශම බිංදුවයි පහක් විදිහට බලන්න. What is your T value? What is your T value? මේකෙදි බලන්න එහෙමයි. මෙතන ඒරියා එක 100ට 5 නම් මේ ඒරියා එකෙන් තමයි ෆලෝ කරන්නේ. So this is 0.05. Rejection critical region. බලන්න කීයද එන්නේ කියලා. Follow up your T distribution. Degree of freedom 15 and so level significance level 5%. What about it? Find out what is that value?
1.7531.
1.7531 minus. That's correct. Minus 1.7531. Minus 1.7531. Minus 1.7531. That's correct. Minus 1.75 is your critical value. Minus 1.7531. හරියට බලන්න පුරුදු වෙන T distribution එක 1.7531. Now this is your value. So then area of critical region 0.05. So then minus 1.7531. Minus 1.7531 is correct. Now analyze your sample data. Now this is a T distribution. T is equal x bar minus mu S over root 10. S over root 10. Now this is your T value. What is your x bar? X bar is equal 199. Mu is equal to 200. Mu is equal to 200. S is equal 2.5. 2.5 and N is equal 16. N is equal 16. Calculate your T value. 199 minus 200 divide by 2.5 over square root 16. Square root 16. T is equal minus 1 over 2.5 divided by 4. එතන මේ 4 එක උඩට ගන්න. Minus 1 into 4 divided by 2.5 minus 4 over 2.5. What is your T value? Minus 4 over 2.5. 4 over 2.5. That is 1.6 minus 1.6 minus 1.6. Your T value is minus 1.6. What will happen? Your boundary is minus 1.75. So then minus 1.6 goes to the acceptance region. So H naught lies into acceptance region. H naught lies into acceptance region. So H naught accepted. So what will happen? H naught accepted. Again, what is that? So then volume content in bottle of soda is exactly 200 milliliters. අඩු නෑ ඒක. So then consumer's claim goes to be wrong. So then the quantity of liquid. The quantity of liquid contained in a bottle of soda is less than 200 milliliters is rejected at 5% level of significance. මේක යන්නේ is the consumer's claim is accepted or rejected නේ. එයා කියන්නේ මොකක්ද? ඒක අඩුයි කියලා. ඒක වැරදි. So then write your conclusion. Write your conclusion. Conclusion. The quantity of liquid containing in bottle of soda less than 200 milliliters is rejected at 5% level of significance. So now this is the way of making testing hypothesis. Two questions are there. Exercise දෙකක් තියෙනවා. Exercise number 1. The manager states that the average daily sales has exceeded 200 units after the newly launched advertising propaganda. Once the sample of sales of 36 days was checked, the mean and the standard deviation have been computed as 225 units and 36 units, respectively. Point out whether the opinion of manager is accepted or not at 1% level of significance. මොකද්ද මේක? මේකත් මේ જાතියම ගානක්. The manager states that average daily sales exceeded 200 units after the newly launched advertising campaign. මේකෙදි so how we build up hypothesis statements. එයා ඉස්සෙල්ලා කියනවා so then how many units earlier ඉස්සෙල්ලා 210යි. So then after new advertising campaign it is exceeded as 210. එතකොට මේ වගේ දුන්නාම අපි ලියන්නේ H naught is equal to 210 and greater than 210. ඉස්සෙල්ලා තිබුණේ 210යි. හැබැයි but after the new advertising campaign it has been exceeded 210. මේකේ so then 200 milliliters is volume content. So then the consumer claims that it is less than 200. එතකොට මේකේ නම් එක පැහැදිලිව තියෙනවා. So there is after one technique. So then after the new advertising propaganda, so it has been exceeded 210. එතකොට දෙවනි method එකෙන් තමයි so they builds up hypothesis statements. So then what will happen? So then they check the sample with 36, a large sample, so and have been computed as 215 units and 36 units respectively. එතකොට මේකේ standard deviation එකක් 36, n කියන එකක් 36. So then after the sample of sales of 36 days, දවස් 30ක sale එක check කරපුවාම mean is 225 and then standard deviation is again 36 respectively. Point out whether the opinion of manager is true or false, acceptable or not at 1% level of significance. Now, given that the population, sample mean and sample standard deviation, a large sample, so then case 3 is out. Case 1 out. Which case? So build up your statements by using this method. And then check this under 1% level of significance. That is your exercise 1. Exercise 2 again, the mean weight of the nicotine included in a particular type of cigarette is about 40 milligrams according to the statement made by the manufacturer. එතකොට සිගරට් හදන කෙනෙක් කියනවා එයාගේ සිගරට් එකේ තියෙන nicotine content එක nicotine කියන chemical එකේ content එක is about 40 milligrams, milligram 40යි. A sample of 25 cigarettes taken at random and checked for nicotine content and result were 41.2 milligrams with the standard deviation of 2.4 milligrams. Check this claim at 5% level of significance. So again, he says that exactly 40 milligrams. Manufacturer nicotine content as exactly 40. So then it is greater than or less than. Here there is no word as at least or at most. Make at least at most කියලා word එකක් නැහැ. ඒ කියන්නේ like your example 1. හරියට මහතලියයි not equal 40 is your alternative one. The sample of 25 cigarettes were taken. එතකොට small sample එකක් අරගෙන තියෙන්නේ sample mean is 41.2 and standard deviation is 2.4. Now verify whether case 1 or case 3. So then check the claim at 5% level of significance. 5% level of significance. So what about these two questions? තනියම හදාගන්න පුළුවන්ද? Do you have any confidence to do these two questions? පුළුවන්ද හදන්න? Two questions. හදාගන්න පුළුවන්ද ගණන් දෙක? දැන් හදනවද නැත්නම් අද හදලා හෙට බලනවාද උත්තරේ? මොකද්ද කරන්න පුළුවන්? Can you do it? මම දැන් ඔය කියපු ඉන්ස්ට්‍රක්ෂන් එක පුළුවන් ද හදාගන්න ගන්න. ගණන් දෙකම. එකක් නෙමෙයි දෙකම.
මිස් හදලා උත්තර බලමුද?
හදලා උත්තර බලමු. ආයෙම කැමතිද? එහෙනම් හදන්න බලන්න. හදන්න බලන්න. හරි. එහෙනම් හදන්න ගණන් දෙක පුළුවන් විදිහට හදන්න by taking 15 minutes. ඊට පස්සේ මම උත්තර බලලා දෙන්නම්. ඒතර වැඩේ ඉවරයි තමයි. හදන්න බලන්න. 10-15 minutes වැරදුනක් කමන්නේ හදන්න බලන්න ගණන් දෙකම. So then we'll check our answers. Right, do it. හැමෝම හදන්න. උත්තර බලමුද? හරිද? හැදුවද? Shall we check the answers? උත්තර බලමුද? හදලා ඉවරද ගන්න? ගණන් දෙක හැදුවද? උත්තර ටික බලමුද?
බලමු මිස්.
ළමයි හරි බලමු නේද? හරි. Right. First question, question number 1, exercise number 1. The manager states that the average daily sales has exceeded 200 units after the newly launched advertising propaganda. Once the sample of sales of 36 days was checked, the mean and the standard deviation have been computed as 225 units with the 36 units respectively. Point out whether the opinion of manager is acceptable or not at 1% level of significance. So then he says that. So then the 210 units is exceeded after the new advertising campaign. So that is the second method. Method 2. Method 2 H naught mu is equal to 210. H1 mu greater than 210. Mu greater than 210. Type of test, one tail test. One tail test, but right tail category, right tail. Right tail test. So this is a normal distribution, the large sample. Normal distribution, case 2 high, case 5 high. So then the sample mean and sample standard deviation is given. Sample mean and sample standard deviation. Normal distribution, what is alpha? The 1% level of significance. 1% level of significance. Alpha is equal 1%. Alpha is equal 1%. 0.01. Now this is with one tail test. Locate your critical region on right edge of a distribution. Right edge එකට යන්නේ දැන් 1%. Rejection area is 1%. 1%. සම්පූර්ණ 1% එකම යනවා මේ පැත්තට 1%. මේක 1% නම් so what about the blank area? 49%. 2.33. මේ තමයි critical region. Analyzing sample data. Analyzing sample data. Z is equal x bar minus mu S over root 10. S over root 10. Case number 2 or case number 5. X bar is given 225 units. Mu is equal 210 units. Standard deviation is 36. Mean and the standard deviation. N කියන එකක් 36. Z is equal x bar 225 minus 210 divided by S 36 divided by root 36. එතකොට මෙතන එනවා 25 or 15 then 15 divided by 36 over 6. ඒ කියන්නේ 6යි නේ 15 over 6. 15 over 6. 2.5. Z is equal to 2.5. Z is equal to 2.5. ඒ කියන්නේ rejection area එකට යන්නේ. Rejection area එකට යන්නේ. H naught lies into rejection region. H naught rejected. Again, H1 accepted. H1 accepted means it is greater than 210. Conclusion. Manager කියන්නේ මොකද්ද? It is has exceeded 210 units. එතකොට මොකද්ද වෙන්නේ? Manager, point out whether the opinion of manager. The opinion of manager is accepted at 1% level of significance. Opinion of manager is acceptable at 1% level of significance. Opinion of manager is acceptable at 1% level of significance. Got that answer? Uttare avada ehema? Got that answer? Avada uttare? කවුරු හරි හැදුවද මේක හරියට? Got it? ලිව්වද හරියට conclusion එක? Yes. Right. මේ වගේ එකක් හදාගන්න පුළුවන් කියන්නේ that's okay. Right. වැරදුනා නම් අනිත් අය බලන්න any mistakes were about that. හරියට conclusion එක ලිව්වද? හරි calculation එක ගත්තද? If you have any mistake, make your mistakes by taking 2 minutes. Then again, turn to the next one. ඊළඟ එකට යන්න අපි ඊට පස්සේ. හරි නේද? අපි යන් ඊළඟ එකට. Exercise number 2. Exercise number 2. The mean weight of nicotine contained in a particular type of cigarette is about 40 milligrams according to the statement made by manufacturer. He says that exactly it is 40. A sample of 25 cigarettes taken at random and checked for the nicotine content, and the result is 41.2 and with a standard deviation of 2.4. Check the claim at 5% level of significance. This is under case 3. Small sample. So with a sample standard deviation. හැබැයි මෙතන මට පොඩි අරුපාරුවක් වෙලා තියෙනවා. The weight of nicotine is normally distributed කියලා මට ලියන්න බැරි වෙලා තියෙනවා. So then it should be given. එකක් දෙන්න ඕනේ. නැත්නම් from a normal population. Non-normal population වල small samples වලට ඇත්තටම no, there is no sample distribution. Really they have to give that population is normally distributed. ඒක නම් මගේ mistake එකක් මම හිතන්නේ. So anyhow එතකොට ඒ වගේ ඒවා දෙන්නේ නැහැ. Sampling distribution එක අර්ථ දක්වපු නැතිව දෙන්නේ testing hypothesis වලට. Now it is definitely normally distributed. Weight of nicotine, the contained in cigarettes is normally distributed. ඒක ඇලොක් නම් දෙන්න බැරි වෙලා. A question under case 3. He says that exactly 40 milligrams. හරියට මාතලියයි කියලා කියන්නේ. So then not there is no word as at least or at most. Equal and not equal. Two-tail test. Right. H naught. Mu is equal 40. Mu is equal 40 and not equal 40. Not equal 40. Type of test. Two-tail test. Case 3. Under case 3, two-tail test. So this is a T distribution. T distribution. Now to find out the critical value, you need the what is alpha. Alpha alpha is 5%. Alpha is equal 0.05. 0.05. But degree of freedom, this is a t value. Degree of freedom, sample size minus 1. What is the sample of 25? 25 minus 1, 24. 24. Degree of freedom is 24. So, now here what will happen? The critical region goes the either side. Alpha over 2 gonna making. Alpha over 2. Alpha over 2 is 0.025. Alpha is 0.025. So then you mark 0.025 on both sides. But degree of freedom is 24. Degree of freedom 24. 0.025 on either side. Now follow up your T distribution. T distribution, degree of freedom 24 with 0.025. 0.025. What is your table value T? 24, 0.025. T distribution, what is your T table value? 2.064. 2.064. Dave. 2.064 on both sides. ඒක නෙමෙයි දාවේ. තමලට ඕගොල්ලන්ගේ ටේබල් එකේ තව ඩෙසිමල් එකක් වැඩිපුර ඇති. 2.064 T value එක. Degree of freedom is 24. 0.025. 0.025 is 2.064. 2.064 is your T table value. හරියට බලන්න T table එක. So, analyzing sample data, x bar minus mu, s over root 10, s over square root 10. X bar is equal 41.2, mu is equal 40, s is equal 2.4, n is equal 25. T is equal 41.2 minus 40 divided by 2.4 over square root 25. 1.2 divided by 2.4 over 5. Make a pahing ready karanda. Divide by 2.4. What is your T value? Calculated value is 1.2 into 5. Divide by 2.4. 2.5. 2.5. 2.5. T value is 2.5. Goes to rejection region. 2.064 is your the boundary value. So H0 lies in rejection region. H0 rejected. Write your conclusion. H0 rejected means H1 accepted. H1 accepted. Write your conclusion. මේක කියන්නේ check whether the claim of check this claim. What is this claim? Type of cigarette is about manufacturer's claim. Manufacturer's claim is rejected at 5% level of significance. Manufacturer's claim is rejected at right. Now this is your answer. Any mistake? So you make your mistakes. Mistake එකක් තියෙනවා නම් හදාගන්න. So then you have to know how to follow up your T value, T table. T table එක බලන්න හැටි Z table. So how to build up to the hypothesize the statements. So then by using method 1 or method 2, method 1 එක lazy. So how to decide the critical region. So under which case, ඒ ටික ඔක්කොම හරියට බලලා do this all questions once again. ඔයගොල්ලන්ගේ exam එකට අහන්නේ මේකෙන් විතරයි කියලා දාලා තියෙනවා testing areas වල. හැබැයි මේකම තමයි යන්නේ අර අනිත් distributions වලටත් mu1 minus mu2 p p1 minus p2. මම ඒ ටික දැන් කරන්න බලාපොරොත්තු වෙන්නේ නැහැ මොකද ඔයගොල්ලන්ට තව chi-square distribution එක කරන්න තියෙන නිසා. ඒ හින්දා දැනට ওই ගණන් ටික හදන්න. ඊට පස්සේ අපි before the final exam ඒ ටිකත් අපි complete කරමු. මොකද final exam එකට ඒ ටික එයිනේ. මේකට එන්නේ නැති නිසා. ඊට පස්සේ so then 2.8 is chi-square distribution මම ඒක දාලා තියන්නම්. එතකොට ඔයගොල්ලන් දැන් වෙන්නේ මොනවද exam නැහැ නේද? මේ සතියේ කරන්න පුළුවන් නේ දිගටම නේද 27 වෙනකම්? මම එන හෙට ආපහු සැරයක් so then the next class will be on tomorrow. හෙට කරන්නම්. හෙට ඉඳන් මම දිගටම කරනවා classes. හෙට 9ට class එක කරමු. ඒකෙදි මම කරනවා chi-square distribution. ඒක තමයි අන්තිම එක chi-square distribution 2.8. මම ඒකත් ඔයගලන්ට එවලා තියන්නම්. chi-square distribution එක. එතකොට මේ ගණන් ටික ආපහු හදන්න මේ ටික හොඳට තේරුණාට පස්සේ 2.8 එක විතරයි තියෙන්නේ chi-square distribution එක. එතකොට ඒකෙන් ඉවරයි අපේ මේ දීලා තියෙන එක chi-square distribution. මේ ඒක මම කරන්නම්. එතකොට මේ හෙට. එතකොට ඔයගොල්ලන්ගේ chi-square table එක අරන් එන්න හෙට. දැන් මම නවත්තනවා class එක. එhmenan අපි හෙට රෑ 9ට class එක. 9 o'clock. Right? හරියටම ගණන් ටික හදන්න.